Yes, hi guys. So today let me continue from the singular points. The type of singular points I discussed about. There are two groups of singular points. First point I've discussed that there were multiple points, especially the double points we discussed about double points, triple points, multiple points, or rth order or nth order points. So double points we discussed about, then double points were divided into nodes, cusp, and conjugate points, etc. So we have discussed that in detail in the previous two lecture series, 76 and 77. And today I'm discussing about the second part of singular points. Okay, second part is points of inflection. Points of inflection. Today I'm discussing about points of inflection. This is the second group of singular points. Okay, so what are the points of inflection I'll discuss about. Then what are the concave and convex curves. Okay, then when the convex and concave curve both together, if they are crossing a tangent line of it, okay, then at any point, that point is known as point of inflection. I'll just discuss about it's okay. Then test for concavity and convexity we will discuss about. What the process of finding the points of inflection. Okay, the test for point of inflection, how we have to find out the points of inflection and how we have to prove that are discussed in the end. Okay, and then these questions, students' queries are taken here. Okay, so then we will discuss these questions here. These questions are mainly based on point of inflection. Okay, they are asked by the students. Then I'll clarify them, and this will clarify what is the points of inflection. Okay, so points of inflection, let me first define. The definition of points of inflection is that a point, this is definition here. I'm defining what is the point of inflection. Definition. So a point, let me talk about a point on a curve. On a curve. A point on a curve. On a curve at which the curve crosses it. The curve crosses it. Tangent, at which the curve, let me write here, at which the curve crosses its tangent. What does it mean? If a curve crosses its tangent at a particular point on the tangents, and then that curve is known as that point is known as point of inflection. If a curve crosses its tangent, it is unusual thing. It is very extraordinary behavior of a curve that it crosses its tangent. Usually it doesn't happen, or ordinarily a curve never crosses tangent. But when it crosses its tangent, okay, that point is known as point of inflection. Its tangent, that point is, okay, a point on a curve at which the curve crosses its tangent is known as a point of inflection. A point of inflection. Very important point. Okay, the curve crosses its tangent at a particular point. That point is known as point of inflection. That point is lying on a tangent as well as on the curve. So the curve crosses its tangent at a point. That point is known as point of inflection. I will define that. What is the usually? Let me note down here. Note here that this is an extraordinary. This is an extraordinary behavior of a curve that it exhibits its behavior of crossing its tangent its crossing is tangent at a point. At a point. Usually, a curve never crosses its tangent. But this is an extraordinary behavior. Okay, usually a curve never crosses its tangent. This is an extraordinary behavior. Okay, this is noted down. Okay, this is an extraordinary behavior of a curve, that it exhibits its behavior of crossing its tangent at a point. This is an extraordinary behavior. Otherwise, a curve never crosses its tangent. Okay, so this is something introduction point of an ordinary point. Okay, or point of inflection. I mean, point of inflection of a curve. Now let me talk about what is the point of inflection. But before describing point of inflection, let me talk about what are the concave and convexity, concavity and convexity of a curve. So, convex curve or concave curve. Now, concavity and convexity of a curve. What is the concave curve? What is a convex curve? Let me discuss about. Okay. First, let me draw some graph here. Okay. Now, if I take this line as the and this is the tangent line of a curve. Let me take this curve as and here it is the point A. Let me take A, B, and C. This point. This is x-axis. Origin O. This is y-axis. This is x-axis. Now this is a point. This is an acute angle. Okay, and let me take here A point. This is A point here. I've taken point A. Point ABC is an acute angle. Angle ABC is an acute angle. Is an acute angle. Right. Similarly, let me take here another curve with a tangent line, and here this tangent is curve is inside this, and here A point is this. Let me take. Okay, and again this point is B, and this C point I have taken ABC. This is again x-axis, 4 point y-axis. Or we can take this line, not x-axis, but another line. We can take another line also. Like, let me take here. This is a line here, tangent line. Okay, and this is a curve. This is a curve here. Let me take A, B, C. This is underline. Okay, so this point can also be taken. So I'm taking here. I've taken the axis of x, but this can be underline BC. Underline BC. Okay, which is making an acute angle here. So this curve is convex curve or concave, I just described. And now in this case, this acute angle, if it is included in the curve, here this is not included. This curve is not included in the acute angle. So this is a convex curve. Okay, and this curve, which is included in the acute angle, this acute angle includes this curve. So this curve is known as concave curve. So let me write here. Or here also we can describe about this the tangent line, and this is another line. Or let me take acute angle here. This is acute angle. Again, this is BC, and this I have taken a curve here. This is A point. So this acute angle again includes this curve. So this is concave curve. Concave curve is this, and this is convex curve. Okay, so let me write here. If AB is the tangent AB is the tangent to the given curve, and ABC is the acute angle, which includes the curve. Or does not include the curve, or does not include the curve, or does not include the curve. Okay, or does not include the curve. So this angle is not including the curve. Curve is above the tangent line. Now in this case, the tangent, the curve is below the tangent line. This acute angle including the curve. In this case, this curve which includes the curve, this acute angle which includes the curve, then this curve is known as concave curve. This is convex curve because this curve is not included in the acute angle. Okay, so we can take another way. So AB is the tangent to the given curve, and ABC is the acute angle which includes the curve or does not include the curve. Okay, these are two cases here. Let me take this is the first figure first, and this is figure number 2. Let me take figure 2. So what is the first figure? In the figure first, let me write here. In the figure 1, the acute angle includes the curve. So the curve is here. So the curve is a concave curve. This is a concave curve. CONCAVE. Concave curve. Okay. So this is a concave curve. The acute angle includes the curve. Then the curve is known as concave curve. Okay. And in this case, the acute angle is not including the curve. The curve is convex curve. Okay. This is the definition of this. Now let me talk about figure number 2. Now in figure number 2, this is convex curve. Let me now discuss about this. Okay, in figure 2, this one, the acute angle does not include the curve. So this curve is a convex curve. Right? Convexity or concavity of a curve are both described here, defined here. So defined here what is the convex curve, what is the concave curve. Now let me discuss about the situation that when one curve is below the tangent line, other is above the tangent line, a portion of a curve. If a portion of a curve, let me describe here. If a portion of a curve, this is the tangent line here. If a portion of a curve like this is a portion of a curve. One portion of a curve is convex. This is convex here, and at this point A, let me take. So here this curve is, this point A is known as point of inflection. So let me take here, when a part of a curve is above the tangent line, the tangent and another part below the tangent, and another part below the tangent, below the tangent. Okay, then the point A here, then the point A here is a point of inflection. Is a point of inflection. Then this point is known as point of inflection. Simple question. Now let me take what is the test for convexity and concavity of point of inflection. So let me talk about convexity and concavity. Test for that. How do we test that? Let me now describe those points. Okay, again let me take two figures here. Let me take two figures here. This is x-axis O, x dash axis y dash axis, again y dash axis, y O origin, x dash axis, and this is x-axis. Okay. Now let me take in this situation. There is a tangent line again. This is a tangent. Okay, and if I take a point A, here. Okay, this is concave curve, and if I take another point, let me take B on both sides. This is B point here. This is B point here, and from B, this is a curve. Okay, and from B, if I draw perpendiculars on axis of x, okay, and let me draw from A also. We draw perpendiculars from A, B, and this perpendicular crosses A and B are the points. This point is x plus h, y plus k I have taken, and this is x, y point. So A point is x, y, and B is x plus h and y plus k point. Here also the same point, x plus h and y plus k. So B point on both sides we have taken. X plus h and y plus k doesn't matter. This may be x minus h or y minus k. That is not the point. So we have taken similar type of points B, okay, on both sides. And then we draw perpendiculars on axis of x. Axis of x, suppose they are meeting at point. Then we take here C. Okay, and this is let me take C here. This is C point, this is D point, and this is also D point. Okay, A, B, C. So we have taken A. So a point A on a curve at which the tangent, okay, is drawn. Okay. Now if we take another point B, x plus h, y plus k, another point on the same tangent line, okay, on the same curve here. So I have to take, this point B. Now this is B dash I have taken. This is B dash I have taken. This B point is here. This point, let me take this B point. This is B dash, but these points are coordinates of this point are not this. But let me take this point B is here, and this is B point here. This is B dash, okay, on the tangent line. But on the curve we have taken B point. So this B point is, x plus h and y plus k. This point is this. So on the curve we have taken the points, not on the tangent line, but on the curve we have taken 2 points A and B, the coordinates of which are x by and x plus h, y plus k. Similarly here also x plus h, y plus k, x plus h and y plus k. Now let me take here again. There is a curve, convex curve here, and there is a tangent line. Here also we draw perpendiculars. I have taken here again A point. This is B point on the curve. So on the curve we have taken B point, and this is x y point A, and this is again B point. On both sides we have taken the point x plus h and y plus k on the curve, not on the tangent, but on the curve we have to take the points. Again from this B point also we draw perpendicular. Okay, we have drawn the perpendiculars here. Again I have taken here D point, this is D point, and this is C point. Okay, same situation here, but again this is B1 point. This is, let me take B dash, not B dash, but let me take B1 here. B1. Okay, so this is B1. This is not B dash, but B1. Let me take. No problem. Okay, now let me test of we are discussing about test of convexity and concavity. Test of convexity and concavity. Okay, convexity and concavity test we are discussing about. Let us take a point A. Let A x y be a point on a curve. Be a point on a curve. Now the curve can be convex or concave. This is convex curve here. This is concave curve here, which I have already described. Now let me take another point on a curve, and let us take bx plus h y plus k another points, or on both sides of B. This another point on both sides of A on the curve. Another point on the curve. Another point on the curve on both sides of A, which is x, y. Try to understand. Then drawing perpendiculars from B to axis of x, from both B's, Okay, so and these perpendiculars are, let me describe them. BD perpendiculars, BD and BD, which intersects the curve, which intersects the tangent in this case, which intersects the tangent at B1. At B1 points. Tangent is being intersected by these perpendiculars at B1 point. This is B1 point, tangent is intersected. In this case, above the curve, okay, these B1 points are above the curve. And in this case, this is below the curve, because tangent line is below the curve. Okay, so, but B1 point we have taken. So not a problem at all. Okay. What we have done, BD perpendiculars we draw, but we extended that up to tangent line. So tangent is being intersected by this point B at B1, by this perpendicular at B1. Okay, similarly here, tangent is intersected at B1 points. But on the curve we have taken B point. On the curve we have taken B point. This is B point. Coordinates are x plus h and y plus k of B point. Y plus k. Now in both the cases, if convex or concavity, let me prove. In case of convex curve, okay, now let me take the difference of these points. What do we have? We have BD minus here BD minus B1D. B1D. This BD minus B1D or BD minus B1D. B1D. If this difference we have to find out. If it is positive, BD minus B1D is greater than 0. Or it can be B1D is negative or BD minus B1D is less than 0. This is in case of convex curve. This is convex curve here. Convex curve. In case of convex curve, it is positive. In case of concave curve, it is negative. Concave, sorry. This is concave curve. In case of concave curve, BD minus B1D, in case B1D minus BD, or sorry, BD minus B1D is negative, because B1D is greater than BD. So this BD minus B1D is less than 0, is negative value. And in this case, in case of convex curve, which is this one, BD minus B1D is positive value. This value is positive. Now let me find out its values. Okay. First let me take this. What is the BD here? So BD, this is Fx plus H. BD is Fx plus H. This is the point BD. B is on the x plus H. So this is sorry, let me first find out what is the equation of the tangent on A point. Now equation, first let me find out what is the equation of a tangent at A is given by let me take y minus small y minus y1 equal to f dash x, which is f dash x here, into x minus x is small x. Now in this case, x and this capital Y are the points x plus h and this. So if I substitute x plus h, putting capital X equal to x plus h, because this x and y are the coordinates on the B point, on the curve of B point. This x plus h, if I replace, it will be y is equal to, this is small y taken to that side, it will be small y f dash x into, within bracket it is x plus h, in place of x, capital X minus x, x's cancel out, this is h into, this is y plus f dash x into h, and this is h here, h into f dash x. Try to understand. But this, what is y here? Y is fx. Value of y on the curve. Equation of the curve is y equal to fx. Okay, here y equal to fx. And capital Y, this capital Y is fx plus h. So this equal to fx, y is fx plus h into f dash x. Let me take this is equation number 1. So this capital Y value is this much. Now let me write here. The capital Y, which is the point on the curve y here, equal to small y. Sorry, this is the value of BD here, because BD is on the point curve. This is value of BD. BD is y here, which is equal to fx plus h into f dash x. This is equation number 1 I have taken. This value of BD. What is B1D? Let me talk about that. So BD is by, I'm sorry, not this BD, but this is B1D. B1D is fx plus h, because this is fx here, the curve fx, or maybe taken this as fx here, h plus h f dash x is that value. Now B1D in this case, if I take fx plus h, sorry, B point, here BD is BD, the distance is fx plus h. What is fx plus h? So this is the B point is lying on the curve, so its value is fx plus h, because this point A is fx and this is fx plus h. But this by equation, by now if I extend this or expand this with the help of Taylor's theorem, this is known as fx plus h into f dash x plus h square upon factorial 2 into f double dash x plus h cube upon factorial 3 into f triple dash x plus and so on by Taylor's theorem. This is by Taylor's theorem. Try to understand. Okay, therefore BD minus B1 minus BD if is less than 0, then if I take B1D minus BD, the difference in case of this will be equal to B1D minus BD. So this value, this B1D is this value, sorry, or BD minus this BD minus B1D we are talking about, I'm sorry, same value, this B1D minus BD. If it is positive, then what is the value of this? So BD minus B1D, this equation, BD minus B1D, now BD is this value, Taylor's theorem. So let me write here the same value. This is the same value, fx plus h into f dash x plus h square upon factorial 2 into f double dash x and so on, minus sign. Second value B1D is this is fx plus h into f dash x. Okay, these two values. So these two first terms, fx and f dash x, are cancelled out because it's negative sign. This value, positive value, will remain. So what is this value? Finally, the difference of these two is left over with us is, let me write here. That means BD minus B1D is equal to this value, h square upon factorial 2